All right, we're in lesson number 3, working through today's lesson is going to be on real numbers and classifying their classifications as well. I will also do, here's your homework assignment, I will also work you through number 18 and number 29 on your homework. I felt that those two were, of all those on that page, probably a little more difficult than the others. So I'll work you through 18 and 29 at the end of this video. But we're going to work on classifying real numbers. So let's just talk about real numbers. I'm going to give you just an easy definition of a real number. A real number is basically any number you can think of. I mean, you name a number and it's going to be a real number. -2, -6.7, 4.5, anything that you can think of. Pi, 3.14, you know, all those are all real numbers. And so we're going to kind of draw a big box that's going to represent kind of like the universe of real numbers. Let's see if I can get this all on the page here. This box is going to represent real numbers. And anything that's a real number is going to belong inside this box. So any number that you can think of belongs in that box. If you can't think of it, it's going to be outside this box. And I'll give you some examples of those in just a bit. So can't think of, or can't maybe dream of. And I'll give you examples of those in just a bit. All right, once you talk about all those numbers that you can think of, we can start breaking those numbers into two big classifications. Most of those we can break into two big classifications. One classification is going to be rational numbers. And another classification, a smaller one, is going to be irrational numbers. So we have rational and irrational. Rational numbers, these are numbers that can be written as a fraction. Let's go on the side real quick. Remember, we've been talking about if I give you 6, I ask, can you write that as a fraction? You write it as 6/1. 6, even though 6 doesn't look like a fraction, we consider it a fraction because we can write it as a fraction. So we would classify 6 as being a rational number because we can write it as 6/1. There are some numbers that we can't write as fractions, and we call those irrational numbers. I'm going to go above here. I'm just going to define irrational number. An irrational number, just a quick one, is any number that cannot be written as a fraction. Let me open that up a little bit so you can see what I just wrote there. So irrational, this is any number that cannot be written as a fraction. I'm going to zoom in just a little bit now. Alright, now there's two ways of recognizing these. So here are the two ways. Irrational numbers are considered non-terminating numbers, and I'll show you an example of that in just a bit, and non-repeating numbers. So for example, non-terminating means it never does end. For example, 0.5, it ends at 0.5. So we would classify that as, that would be a rational number because we can write that as a fraction. But if it went 0.5, 1, 2, 3, 6, 1, 2, 5, 8, 3, 7, and it never stopped, never quit, that is non-terminating. It never does terminate, it never does stop. And we would classify this number right there as irrational, non-terminating. We also consider non-repeating numbers as irrationals. For example, this would be kind of like a non-repeating number. Notice the numbers don't repeat. Something that does repeat would be like 0.56, and then the 6 repeats and repeats and repeats and repeats, like 0.566666, which is going to be 6 with the bar on the top. So non-terminating, never-ending, and non-repeating, doesn't repeat, we classify those as irrational. And you're probably thinking, well, give me an example of an irrational number. One example, a real famous one, is going to be pi. Pi is considered irrational because it's 3.1415, and it just keeps on going. As a matter of fact, if I go to my calculator and I pull up pi on my calculator, here it is. It's 3.141592654. Now my screen doesn't keep going on forever, but if it did, you would see numbers beyond the 4. And I think they've calculated pi out to, I'm sure, thousands and thousands and thousands of decimal places, and it never has repeated. And as the year goes along, we're actually talking about a little bit where did pi come from? How did somebody get that number? We'll talk about that later. But pi is considered irrational because it doesn't terminate, never ends, and it never does repeat. Here's another number. I'll do it on a calculator so you can see it. Square root of 2 is classified as an irrational number. And the reason is notice that it never does end. Now obviously it ends on the calculator, but in the memory of the calculator it goes on and on and on. You can't show that on the screen. And notice it never does repeat. Here's one that is, for example, 1 divided by 3. That one's going to be a rational number. Notice that the 3's repeat there. All right, so that one's going to be rational, and the other two would be irrational. All right, so we got a feel for irrational numbers. Let's keep breaking it down. Once we get into rational numbers, we can look at some other sub-classifications. So the next sub-classification is going to be integers. And I'm going to down below define, oops, you need to be able to see what I'm doing. So there are integers. Integers is all integers, you could say, are going to be a classification of rational numbers. And I'll down below, I'll define what a rational or an integer is. And it's probably easier to actually show what an integer is. So an integer is going to be this. Let me write it first, and then we'll talk about what this means. All right, integers are basically -3, -2, -1, 0, 1, 2, and 3, going on forever this way and going on forever this way. Those are integers. So like -5 would be an integer. 10 would be an integer. Even though it's not written here, 10 would be an integer. 0, -2, a million would be an integer. -1 million would be an integer. 1.5 would not be an integer. 2.3 would not be an integer. Okay, so basically numbers that don't have decimals are considered integers. Okay, we can take integers, we can break integers up. We can break integers up into what are called counting numbers. I messed up. I'm ahead of myself. Whole numbers. And whole numbers I'll define, let's see, make sure you can see that. So there's whole numbers. Remember, if you ever need to stop the video, go ahead and stop the video so you can get the image and get the information. Whole numbers. And whole numbers are very similar to integers, except they don't have negative numbers. So they actually start at 0. So 0, 1, 2, 3, ... So 5 would be a whole number. 6 would be a whole number. 100 would be a whole number. But -1 is not a whole number. -2 is not a whole number. So you get a feel for that. Okay, the last classification is integers. Sorry, last classification is counting numbers. So let's go through counting numbers down below. Counting numbers are easy. Actually, counting numbers are also known as natural numbers. Counting numbers. Here's how you know counting numbers. If I ask you to start counting, what would you start with? Would you start with 10 and count? No, when you were little and they asked you to start counting, you started with 1. Those are your counting numbers. 1, 2, 3, and on out. 0 is not a counting number. -1 is not a counting number. 10 is. 100 is. Okay, so those are your counting numbers. Okay, so let's go back to the diagram. And remember, I told you we're going to talk about some numbers that you can't think of, that we don't classify as real numbers. Let's do a couple examples. Let's do one example. I kind of put them out in the cloud here because really they're kind of weird. And they're called imaginary numbers. And I'm going to spell imaginary wrong, I have a feeling. I hope I got that right. Imaginary numbers. Imaginary numbers are like square root of -4. Let's think about that. If I go to my calculator and I plug in the square root of -4, look at what happens. I get an error. It doesn't allow me to determine what the square root of -4 is. So easy examples of imaginary numbers are negatives underneath the square root, like -9, -16. Those are all imaginary numbers. All right, I told you I'd do 18 and 29 from your assignments, or from your lesson number 3. So here's 18 and 29. Remember, I'm not going to do the identical problems, but I'll do problems that are going to be similar in nature. So we'll do 5 times 2 plus 6 minus 10. Remember, we do inside the parentheses first, so we're going to do the multiplication first. So there's 10. 10 plus 6 is 16. You really don't need the parentheses there, and you get 6. So I think the hardest part on this one is just remembering to do the multiplication inside the parentheses first, and then do the addition. All right, let's do the next one, number 29. 29 is a little bit stickier, so let's do 50 minus, let's do 5 plus 2 times 3 plus 4. Okay, we're going to start inside the parentheses first, and we have addition, we have multiplication. Remember, we do multiplication before we do addition. So I'm going to do 50 minus 5 plus 2 times 3 is 6. Remember to bring down everything, and don't do the steps in your head. Just put them down on paper. Okay, so get in that habit, because on the assignments I want to be looking for all the steps. Okay, the next step is to stay inside the parentheses before I do anything outside the parentheses. So I've got 50 minus, there's 11. Bring down the 4, bring down the minus, bring down the 50. Okay, this piece here I think gives people fits, and that's why I wanted to do it with you on the video. That's just simply -11. So you can actually take the braces off there. So that's -11 plus 4. 50 minus 11 is going to give you 39. Remember, we work left to right. Don't do the addition first. Do subtraction first in this case. And then 39 plus 4 is going to give you 43. And there it is.